Okay, in this lesson we're going to talk about families of polynomial functions. And you would have just done the Desmos page on seeing a whole bunch of members of a family of a polynomial family. You would have seen some similarities between all the different functions you saw that correspond to that family. You would have seen some similarities between the graphs too. So our goal here is to be able to come up with an equation to represent the family of polynomials. And then also, on our next example, we're going to look at how to pinpoint an exact particular member of the family of that polynomial, which is a skill that we kind of already know how to do. Okay, so let's say I have this example here, and I have to write an equation that represents a family of quartic functions, and it has these zeros, 0, 2, -2, and a half. So this is a skill that we've gone over before, and I'm just going to reiterate that since the family all have the same zeros, and that's what defines a family of polynomial functions, they all have the same zeros, and the order of those zeros is also the same. Therefore, we can write a function, an equation, using those zeros in factored form. So for this one, I'm going to usually we use an A, and I'll keep using an A. Sometimes the book uses a K, or any variable out here is going to work that will represent the family. Okay, so as soon as I put a variable out here like A, which defines that part of the leading coefficient, that represents all the different polynomials that have these zeros. Okay, so I'm going to say I'm just going to write a factor of x because of this 0 here, right? So if 0 is a root of this equation, or a 0, then x minus 0 is a factor of the equation by our factor theorem. But x minus 0 is just an x. Okay, so then we got an x minus 2 because of this 0 right here. And we've got an x plus 2 factor because of that 0 right there. And then we got a half. Now, sometimes you can write a half as x subtract a half, or you could write it a little cleaner like this. I could say it's really 2x subtract 1. That factor there yields a 0 of a half also. So if I solve that equal to 0, I would get a half. So that's it's a way I can write down that factor a little cleaner than using, say, a half out here or a fraction. It eliminates that need for a fraction. Okay, so that's it. That's the equation that represents a family of polynomials with these 4 zeros. Okay, so let's get a little tougher. Let's do this problem here, which is going to be a common problem. I'm going to determine a simplified equation for the family of quartic functions, and it has these 4 zeros. Okay, so notice there are 4 zeros written here. There is positive 1 and negative 1. So plus or minus 1 is a way for us to write those two different zeros. And also this 0 over here, which is not a nice 0, right? This is not an integer value 0. This is a 0 that if we solved an equation, we had to use probably the quadratic formula, and this popped out as one of the x-intercepts. Okay, so that's 2 x-intercepts. One is 2 plus root 3, and the other one is 2 minus root 3. So we're going to use that, both of those zeros, and both of these zeros to write the quartic function. And we're going to start the exact same way we started the last example, that I'll define f of x to be the function. I'll put that a out front, and then I have x minus 1 for the positive 0 here. I've got x plus 1 for the negative 1 right there. So those are just like the last one. Then I have x minus this 0. So I'm going to take the positive version here, so that's an x, and I'm going to put this in small brackets. So that's 2 plus root 3 right there. Okay, see, make note of this. That's x minus the 1, 0. That's one of the zeros. I'll need another factor for x minus, and I'm going to use the minus version. And notice the minus is only between the 2 and the root 3. So I'll put a bracket here, 2 minus root 3. There's that 0. Okay? So there's my polynomial equation, but I should simplify it, right? I shouldn't have these root 3's, and you'll see in a minute this is going to clean up very nicely. So what I do is I'm going to leave this as x minus 1 and x plus 1. Okay, I'm going to leave it in factored form. I do want to leave this in factored form, but you'll see this in a minute. It's going to clean up a little bit nicer than this. Okay, so what I'm going to do is put big brackets here, and I'm going to expand this out because this does not look pretty. I can make it look like a nice trinomial that's multiplied by this in a little bit better way. Okay, so I'm going to FOIL this out, but in order to do that, or sorry, I'm not going to FOIL it, I'm going to expand this out using the distributive property. But before I do that, I'm going to multiply this negative sign through this bracket just to make it a little bit easier for me to work with. So I have x, and this is going to be now a minus 2 and a minus root 3. So that's that bracket right there. And that's going to still be multiplied by this stuff. So this is going to be x minus this 2 and then plus root 3 right there. Close that up. Okay, and again, I'm going to come down, I'm going to rewrite this stuff, and I'm going to multiply all this out. Okay, so I'm going to expand all this out, which means each one of these terms gets multiplied by each one of these terms. So first I'm going to go x times x. That gives me my x squared. Then I'm going to go x times this minus 2. That's a minus 2x. And x times this plus root 3. So that's a positive root 3 times an x. I'm going to put the x out front of the root 3. Okay, so I don't get it confused by root 3 of x. Okay, so that's that multiplied by x. Now I'm going to multiply all that by the negative 2. So negative 2 times another negative 2x. Negative 2 times negative 2 is positive 4. And a negative 2 times that is a negative 2 root 3. Okay, last one we're going to do is negative root 3 times all of this. So this is negative root 3x. So I'm going to rewrite with the x first. And then I have plus 2 root 3 because of the two negatives, so plus 2 root 3. And then I have a negative times a positive, that's going to be a negative, I know. And then I have a root 3 times root 3, which is just 3, right? Because it's root 9 and then square root it, get 3. Alright, let's clean this up a little bit. You see how this is going to clean up nice yet? I got no x squared terms, so I'm collecting like terms at this point. I got an x squared. I got a minus 2x. I got another minus 2x, so that's minus 4x's. And let's have a look at this. Look at plus root 3, look at this, plus x root 3 minus x root 3. They're going to subtract out to make 0. I've got this, look at this, minus 2 root 3 plus 2 root 3. They're going to subtract out to make 0. And I have left over a 4 subtracted 3, which is just 1. Now look how pretty that is. So my family looks like this. Oops, let me erase that. Okay, so that represents, it's a nice cleaner version than all those roots in there. Okay, so it's still unfactored. We've got these 3 factors. It does have 4 zeros, right? We already determined that. There's one there, and these are also 2 zeros. But this equation just looks a little prettier than that original ugly equation. Okay. Now notice this is not factorable. Okay, we just went from the factored form to the expanded form because it looks prettier than the factored form. So we want to leave it that way in this case. All right, so that's our equation for a family of quartic functions with those 4 zeros up there.